Alright, so now we're going to talk about floating point numbers. So you should use a floating point type whenever you need a number with a decimal, such as 9.99 or 3.14. So there are really two types of floating point numbers. One is float. Float is a 4 bytes wide number system, or 32 bits, and it supports approximately 7 decimal places of accuracy, the 7 numbers after the decimal point. And the range value is approximately very huge numbers, so they can support very big numbers. And double is the most common one. It is an 8 bytes wide, or 64 bits, and it can support approximately 15 decimal places of accuracy, and the range is very huge. So the question here might be that which one should you use? There's one answer to that, is that it depends how many decimal numbers that you need, what is your accuracy, and that's important. But usually double is the most common one if you don't have a memory problem. So generally our programs, we shouldn't have any issue with the memory, so we will stick with double. Even with double, as you notice that there is only 15 places of accuracy. You might, for some case that might be too much even, but think of the pi number. Usually there's an infinite number of decimal points in the pi number, which is impossible to represent with any of these number systems. So let's see an example in the editor. Alright, so let's work on this example that we're going to practice floating point numbers. So in this example, we're going to use the Pythagorean theorem to find the length of the hypotenuse given the length of the two opposing sides. So before we start, we're going to save this as hypotenuse.java. Okay. Not only that I have a hard time saying it, but I have a hard time spelling it. Okay, so we're good. This is Java. Let's get started. So class hypotenuse, and hit enter. Type main, hit tab, maybe hit enter just in case. You don't have to. And I'm going to create two double variables. So double, this time I'm going to use the same line, side 1 and side 2. So in a single line I can define more than one variable. So, and also I'll do one more. This one will be hypot. So all three. So to initialize the side 1 and side 2, you can only give any values. I can say 3.5 or 3.0, and side is 4, side 2 is 4.0. I'll change the values later on. Okay, let's calculate the hypotenuse. So hypot is equal to, now I'm gonna use a math library function. I'm gonna call in math dot sqrt, short for square root. So this function will return the square root of a given value. So what the values is, if you remember from geometry, side 1 times side 1 is basically the square, plus side 2 times side 2. Alright, so we got it. Let's print this out. So I'm going to say PL tab. Then I'm going to say hypotenuse is space plus. Notice that I'm leaving space inside the quotation mark, because when Java concatenates two things together, I want to make sure I have a space in between. So hypot. So we're done. So I'm going to go ahead and type Java. Oh, if everything is good, we should be able to. Oh, I forgot to. So even though I did this mistakenly, I still got a result out. However, if you look at inside the directory, I don't have that class version of it yet. So I have to redo this. Java C, I can properly compile. Now you can see I have that class version, so that I can properly run Java. There you go. So hypotenuse is 5.0. So as we said, double can support decimal values. So I'm going to say put bunch of random decimal numbers. So and compile, run again. Here we go. So that's our result. So that's how we could use a floating point number in calculations.